Hi guys, and welcome back to the channel Machining with Joe. So if you watched my last video, you'll know that in the upcoming set of videos from now, I'm going to be making a knurling tool as featured by Hemingway Kits. So for you guys unaware of what a knurling tool is, I've actually got one of the smaller versions from my mini lathe. So the basic way that these work is you apply a clamping pressure to a set of hardened wheels, and those hardened wheels make a pattern onto the material or workpiece that you want to sort of form. This is great for my mini lathe, but since owning the Harrison M300, which is a much larger lathe, I've not really had a knurling tool suitable to use on that thing. Hopefully then, by the end of today's video, we'd have made a good start on the Hemingway kit and be able to move forward up to upcoming videos to get this thing all finished off. So with that being said, let's head over to the milling machine and make a start on this thing. To start with then, we're going to first of all machine the side plates to final dimensions before coming back and adding any holes or features. So in this kit you're supplied with two of these plates, which are pretty much on final thickness and width, but because my one had this slight bear in it, I had to just go back and skim over the width just to make that a nicer finish. So in this video I'm only doing about 0.1mm depth of cut, and that's really, like I said, just to clean this up and make the overall appearance look better towards the end. So with the part now flipped in the vise, I can go back and just finish off this very light pass. With the sides now parallel to each other, I can use a 1, 2, 3 block just to make sure that these plates are perpendicular in my vise before machining these down to final dimensions. So this is probably one of the only critical dimensions on these side plates, and that's because really you're governed by the thickness and width by the material supplied. So first pass on the top just to get this at a right angle, and I'm left with about 76.7mm. So we're aiming for 3 inches for this, so I've got about 0.5mm left to go, and that's what I'll do on the underside, which is left to be machined. Happy that using my DRO I've got this to final dimensions. I can just check on my surface plate by having these plates clamped to a 1, 2, 3 block. Knowing that this 1, 2, 3 block is 3 inches in height, I can sweep across these and just check the measurements. So on the first side I'm getting about 0.1mm difference compared to the 1, 2, 3 block. So for this build that's completely acceptable. And sweeping across again, I've got about 0.1mm on one and about 0.2mm on the other. So I've got a slight bit of taper on that top plate, but I think for what this is being used for, that's going to be perfectly fine. So next operation to do now is we need to get ourselves a 0 point in the vise so we can know where to drill all our holes. And to do so I'm using my Hamer gauge here again, which since owning this thing it's come into its own really. It makes zeroing out the DRO so easy. So with that now zeroed, we now have a reference point in that far corner which we can take all our measurements from. So the fitting instructions that come with this kit actually give you a bit of a guide of how to machine this and how to build it, and it advises that we drill through for the M6 threaded hole and get these things bolted together as soon as possible before doing any drilling operations like the locating pins or chamfers. So to begin with here then, I'm plunging in with an 5mm drill bit, which will be our tapping size holes for the M6. And because I've chosen to do the bottom plate as the M6 tapped hole, I've just had to quickly take it out of the vise and take it over to the bench where we tap these out to M6. With that all done, just put a light chamfer on there just to clean up those edges, make sure there's no sharp burrs or anything. Now we can move our attention back over to the top plate, and this top plate now receives a generous countersink for both holes to accept the M6 countersunk bolts supplied in the kit. Not forgetting to drill these 5mm holes out to accept the 6mm bolt. I quickly do that and then come back in with the countersink. So for me, there is probably some kind of measurement you could have took to get these bang on each time, but for me I was just going down little by little and every now and again stopping to put the bolt in just to make sure it cleared the top of that plate really. And happy that they're all done, I can now bolt the two plates together. So I think the main reason we're wanting to bolt these plates together is because these next holes that we're going to be drilling need to be really accurate in locating both these plates together, because these are going to house the pivot pins which the pivot arms are going to sit into. So these need to be really accurate and line up when the plates are all bolted together. So with that first one done, I can now move over and start drilling out the second one. So the size of these holes are 6mm again, and after that I'm going to come back in with a 1/4 inch reamer and just clean these up. Through both plates now, I can then switch out to the 1/4 inch reamer and clean these up. So for the majority of this kit I've actually been converting the imperial measurements over to metric, but certain ones like this 1/4 inch ream hole I'm sticking to imperial just because the stock supplied in the kit is also 1/4 inch. Other than that, all the other measurements I've been converting to metric. So the last thing really left to do on these plates is to add the chamfer onto these corners, and as this is more a decorative thing, I'm just using a quick square here to block these up at 45 degrees, and after that I'll come back in with an end mill just to clean this up. So using a bit of Pythagoras' theorem, I can work out how far down I have to machine these to meet the drawing, and for me it turned out to be about 5.6mm. So with them all done now, I can just lay them on the drawings just to give an idea of how the drawings look, and then we're going to come back in and we're going to start on the spacer block which sandwiches in between these two plates. So this is a really simple machining operation. We're already at final width and thickness, we're just machining this thing to length. So using a 1-2-3 block again, just to make sure this is all square in the vise, I can machine this down to final dimensions, and as it turns out I only have to take off about 1mm on that, so not too bad. Just to make sure this part is going to be as accurate as possible, I'm just going back with the Hemingway gauge again and referencing those 0 coordinates that I zeroed in the last part, just to make sure we're still in the right ballpark. With those reference coordinates now double checked, I can carry on machining this part. So the final features left to put in are just these 6mm through holes which are going to allow our countersunk bolts to slide through. So this is a nice final procedure left to do on this very simple part, and from this I can then move on to the next part in the build. not before going back and just adding a little chamfer to these holes and breaking any sharp edges on there. We're going to be leaving the mill now and heading over to the lathe just to do these small pins. So I'm just hand filing some radiuses onto the edge of these pins. These are more of a decorative thing, but it's nice to get them on there instead of a chamfer or a straight edge. After that I can come in with my parting tool and just part these off to length. So before this I zeroed the tip of my tool onto the end of the part on the DRO, and then I've just got these measurements to length from the drawing. And parting these off is a really simple procedure because the stock is already at final dimensions. It's just a case of doing these to length and adding a radius onto both sides. And with those done, I can now assemble the tool for the first time with the parts I've made. So this one here we're going to be naming the bottom plate for this build, and with that bottom plate in place we can put the pivot pins in, put the sandwich block in, and then put the top plate in. And this is the moment of truth where we see if the countersunk screws all line up, and the first one seems to go in there fine, and the second one seems to go in there fine. And just like that we have our final finished product for today's video. With the main body now completed of the knurling tool, it feels about right to sum up this video, and it will lead us really nicely into the next video where we'll be taking on the next challenge in machining the lower and upper pivot arm which attaches onto this knurling tool. So overall first impressions of the knurling kit then, seems like a pretty cool kit. The only criticism I'll give is a lot of the stock that was provided is almost or bang on final dimensions. So for example this block here, which is going to become our pivot arm, sort of thickness wise this is bang on, and length wise there's not really much to play with, and that's been like throughout the whole kit. The majority of parts have been like that, so it's been a real challenge. But overall this seems like a really good experience and a really fun little project to do here on the channel. I hope you've enjoyed this video today guys. If you have, please give this video a thumbs up, and if you haven't already, subscribe to the channel. Subscribing to the channel is completely free to you guys, and it really helps the channel grow and become more popular on YouTube. So if you don't mind, please do that. Other than that guys, that sums up today's video. See you next time. We'll be carrying on with the knurling tool.